Okay, so absolute value can be very simple, but can get also pretty hard, complex. So I'm going to kind of go through what it means. Absolute value is a measurement. So we know like all of the numbers in our number system can be placed on a number line. So here's my number line. I'm going to put 0 in the middle here, and I'm just going to, put a few numbers on here. So here's 1, 2, 3, 4, 5, 6. And if I put some negative numbers on here, they go backwards. -1, -2, -3, -4, etc. They'll keep going. Absolute value measures how far away from 0 you are. So the symbols that are used are these two bars that'll look like this. They just look like two straight lines. But I'll put a number in there like absolute value of 3. And when I see that notation, I read it out loud. I say absolute value of 3. What does that equal? Well, it's actually really simple. Here's 3 on the number line. Here's 0. How far away is it from 0? It's 1, 2, 3. So what's the absolute value of 3? 3. That's how far away from 0 it is. So if I asked you, what's the absolute value of 225? I don't really want to draw a number line all the way out to 225, but how far away from 0 is 225 if you had to count all the way out there? Yeah, it's 225. 225 is 225 away from 0. So the absolute value is just how far away from 0 is something. And so that's our definition, and I'm going to write it up here. Absolute value measures how far from 0, measures how far from 0 a number is. How far from 0 a number is. So let's talk about negatives. What if I had said, what's the absolute value of -3? That's on the other side of the number line. That's over here, -3. Well, it's the same thing. How far away from 0? It's 1, 2, 3. So it's also 3 steps away. You're not going to say it's -3 away. We don't measure things in negative numbers. We're just going to say, hey, it's 3 away. So if I said, what's the absolute value of -23? You'd say that's 23 steps away from 0. So it equals 23. And that's the basic idea behind absolute value. Now, it gets more complex. So to give you an example of how it gets a little bit harder, I could give you some expression that you need to solve, and I'm going to put an absolute value in it. So like I could say, find the absolute value of 3 minus 7, and then I write plus 2. Well, when you see this, you think of your order of operations. You think of, what do I have to solve first? I always want to solve what's inside of this first. So what's 3 minus 7? That's -4. So I have absolute value -4 plus 2. And before I do my plus 2, what's the absolute value of -4? How far on the number line is -4 from 0? It's 4 away. So I really have 4 plus 2, and 4 plus 2 equals 6. So my answer is 6. If I gave you something like this, here's another example, and I said absolute value 2 times -5, and then out in front of the absolute values I had a 3. So it looked like this. Well, first thing you do is the inside. So start with 2 times -5. What's 2 times -5? -10. So I have the absolute value of -10, and then I have a times 3 out in front. And the absolute value of -10 is 10. It's 10 steps away from 0. So really this is just 3 times 10. You can use a parenthesis or a dot or both. And 3 times 10 is 30. So my answer is 30. Now what we're going to be doing in algebra is we're going to be needing some variables. So I'm not going to have just some numbers in these problems. I need some x or y's. So let's look at an algebraic one. What if I told you I had the absolute value of x? A mystery number that I don't know. X is some number, I have no idea what it is. But I tell you that it's equal to 4. What's x going to be? I have some number, absolute value equals 4. Couldn't x equal 4? Because 4, if I put a 4 in here, is 4 steps away. But what else could x equal? Yeah, x could also equal negative 4. The absolute value of negative 4 equals 4. The absolute value of 4 equals 4. They both give you the same answer. So there's two answers to this problem. There's 4 and negative 4. And one of the shortcuts for writing that in algebra is, since it's positive 4 and negative 4, sometimes we write it like this. We put a little plus or minus sign. It's like a positive and a negative sign, plus or minus 4. And that's my answer. X is equal to positive 4 and negative 4. That'll be my value. So if I said, new example, I said that I have the absolute value of x, some unknown number, and I told you that my answer equaled 12. You know there's two things x could be. X could equal positive 12, or x could equal a negative 12. Both of those absolute valued are 12. So you're going to write your answer as x equals plus or minus 12. And that's the answer. We solve for x. Now the big thing we're working on in class is using all this information to graph an absolute value equation. It all comes down to graphing, really. So this is the kind of thing I'll show you that we're graphing. We are working on graphing something where you have a rule, an equation, and it's y equals, but it has absolute values in it. So like I could give you y equals 2x as an example. We actually want to draw a graph of this thing. We've only learned two types of graphs so far in math. We've focused on lines, linear straight lines, which always have a y equals mx plus b rule. And we've also focused on parabolas, these U-shaped graphs, and they always have an x squared rule. Y equals usually something with an x squared and other numbers. So what we're going to do is look at an absolute value graph, which is going to be a new type of a shape, and we're going to see what it looks like. Definitely not, it's going to be something a little bit different in both of these. So let's take a look at it. Here's what I'm going to do. I'm going to sketch my graph down here, set up my XY axis. If you need to pause the video so you can set your own up, probably a good idea. And, you know, when we've learned how to graph, we've learned lots of little shortcuts along the way. Like with lines, we've memorized the slope and the y-intercept. Parabolas, we find the vertex and the roots. There's all these things we've been memorizing. With absolute values, right now, for now, the simplest thing you could do is just make a table. It's the quickest way to get some values and plot some points. So when I see these, the first thing I think of is make an in and out table. The ins are going to be the x values. The outs are going to be the y values. Make an in and out table. And remember, when you set up these tables, you're making it up. So you get to pick the numbers, whatever numbers sound good. I always pick things really close to the center. A couple negatives, a couple positives, like negative 2, negative 1, 0, 1, 2. If you want to pick more numbers and have a bigger table, you can totally go for it. But what you're going to do is take all the numbers that you make up and you're going to put them into the rule. So here's the rule up here. I'm going to be bubbling the x and putting in these ins, these x values, into the rule. So you know how the rule is y equals absolute value of 2x. Well, I'm going to bubble the x, make it a blank spot, and I'm going to fill it in with numbers from the table. So let's start with the first number in the table, negative 2. If I fill the negative 2 in there, I have 2 times negative 2, which is negative 4, but it's in absolute values. And we just practiced this. What's the absolute value of negative 4? How far from 0 is negative 4? It's 4 away. So the answer in the first table spot is 4. Now we got to go through and repeat that process with all the other numbers. So like negative 1 is going to be the absolute value of 2 times negative 1. And 2 times negative 1 is negative 2. So we have the absolute value of negative 2. How far away is negative 2 from 0? It's 2 away. So 2 is our answer. Then I'm going to do the next number, which is 0. So I'm going to have the absolute value of 2 times 0. 2 times 0 is 0. How far away, absolute value of 0, how far away is 0 from 0? That's all 0. So we get a 0 in the table. Now we got to go through and finish these numbers. Let's do 1 and 2 here. For 1, we're going to have absolute value of 2 times 1. And 2 times 1 is 2. So we have the absolute value of 2. And how far away is 2? It's 2 away. And if we do the next number, it's going to be absolute value of 2 times 2. And 2 times 2 is 4. And the absolute value of 4 is 4. And you can see there's always a pattern. It's kind of like with parabolas. You can see how the numbers match up as you move out. 2, 2, 4, 4. I bet the next numbers are going to match up too. They keep matching. But the graph's not going to be a parabola. This is what's weird about it. Plot your points. Let's go put these on the graph over here. So first point in my table is negative 2, 4. So I'm going to go over here to negative 2. And I'm going to count up to 4. 1, 2, 3, 4, and put a dot. That's right at 4. And then I'm going to go do these next numbers. Negative 1, 2 is negative 1 up 2. 0, 0 is at the origin. 1, 2 is right here. 1, 2. And 2, 4, go over 2, up 4. There it is. And check out the graph. It almost looks like one of these parabolas, but it's not a parabola. It's actually sharper than that. It's like a straight V. If I was to connect my dots, they're going in an exact straight line. I'm going to use my ruler here. Look at this thing. Looks like this. And if I go the other way, looks like this. And I chose to start my table at negative 2, but I could have made my table bigger. So it's not like the V stops here. It's going to keep going. So I'll draw some arrows. It's going to keep going both directions. And there is my graph of, what was the rule? Y equals absolute value 2x. And I got my answer. So we now know a third type of graph, absolute value graphs, and they make these sharp-looking V's. So you know how earlier when I was writing notes up here, I said we had learned two graphs this year, lines and parabolas. We now have a third type, absolute value. Absolute value. So there's our third type. So now we've got 3 graphs that we know, lines, parabolas, and absolute values. And hopefully that helps.